So here's how Keycloak can be useful. First of all, it's a web application that runs on a certain port, and you as administrator, you sign in, and it all starts with creating a realm, like demonstrational one, for instance, and then you immediately move to the settings page here, and here you configure how the name of it, and you immediately get an OpenID endpoint, and this is something that you'll be able to use for signing in, like this is the URL we're going to use later on, for instance, and this one as well. So here you configure what actually happens to the realm. First of all, what users can do. Users can sign up, they can restore their password, you know, this email letter thing, and they can click remember me, the checkbox. Also, you define whether you use emails as usernames or you actually want them to have a username. This is email can be used for signing in and some other settings, but these are probably the most useful ones. Email was mentioned. So this solution can also send emails to users for restoring passwords and for verifying emails as well. And you of course have to configure your corporate email, your actual application email in order for this to work. So it can also have a certain theme, so to you it can look like your application. But right now this of course has to be developed. And it can be localized. So you choose some languages that the application will show to the user, and well, basically after all this is set up, you can start using it. There are a few more settings, like for instance, you define how long a user can stay signed in, and you also define some JWT token information like this, also some expiration times and lifespans. But basically after the realm is set up, you go and create a user, like you add one. And when you create a user, the user gets an email or a username if you decided it to be so. The email can be verified from the start, so the user doesn't have to. And a password is created here in the credentials. So you create a password and you of course cannot see it afterwards. And then the user is there. Save. Now, before this user can sign in, we need to create a client. A client is basically an application that can talk to Keycloak and send users to Keycloak. So this application, importantly, has a client ID, remember this one. It also has a URL where the application lives, so this is where authenticated users go. So it's not just anywhere. And here you also configure what the users can actually do. The standard flow is the one using the web page. This is using a password, and this is using a device authentication. I will show all of this. Now, in the backend, we'll need to use a key from here in order to talk to Keycloak, and this is the secret that basically allows an application to get users from Keycloak. So after a user and a client and the realm is set up, we're ready to authenticate. Now we want to sign in as this user. So first of all, in the realm, there is this OpenID configuration, which mentions an endpoint, this one. And this is where users need to be sent by our application in order to sign into the system. So this is the URL. It is also localized, so you can choose the language, which is automatically detected from the browser. Here you can actually sign up, you can sign in, and you can remember your password, and you see, oh, this is all the stuff that we remember that we actually set there. In the URL, the realm is mentioned. The client ID is also mentioned. So this is where the configuration actually comes from. So this is some internal stuff. And we also need to configure where the authenticated user will go. So we specify a redirect URL and perhaps some callback page. This is how normally this is done. So now when you sign in or sign up, and it's a different one, it's my email, the password is correct. So when I sign in, I'm actually sent, you see, to the redirect URL, and here I have some additional information here. The most important thing is the code. This is not the authentication token. It's something that the server would use to actually get my user information. So this token we actually copy, and now we're going to become a backend application and get the user using this token. this is another important thing. We actually need to have some identifier sent by the server and then returned to the server to make sure that this is still the same user, to prevent the so-called CSRF attack vector. But we just got the code, and we're going to use the code in order to get the user from Keycloak. Now Keycloak sent the user to an application, and there is a code that we can use to get information about this user. So first of all, this is like the backend. And first of all, we take this secret that allows the backend to communicate. Remember, in the client there was a secret. Now we get the code. This is the code from the browser. And now we need to make a request to actually get this token. So this is the URL we use for getting authentication token with the information about the user. This is the client that we've created. This is the secret we just set. This is so-called flow. This is how we are going to authenticate. This has to be the same redirect URL, and we're checking the code that the server just gave us. We make the API request, and wow, something doesn't work. Okay, I fixed it. So it was the wrong code. And now if you make a request to the Keycloak server, you're actually getting a response like this. So first of all, it contains your access token. So this is something that you actually use to stay signed in. And you see that it expires in that seconds. It's like in like 30 minutes. This is a different token. It has no authentication information, but just information about your account. So this is the so-called ID token. And when this expires in time comes closer, you need to use this token, the refresh token, to get a new access token. So basically you keep using this one, and when the time almost comes, you use this one to get a new access token. And that's it. Also, there is such an important thing as scope, and this is where basically by asking for a certain scope, you request the server to give you enough permissions and enough information to do something. So this is a standard one. It basically says like, hey, I want account information. You specifically say that you want the email, and there are some other custom scopes, which I will show a bit later. Now, this access token is not just garbage. It actually has information encoded in it. So if you just take this token and copy it over to this JWT.io website, so you take the token, you paste it here, and you see that it's made of 3 parts. This is the header, which specifies the cryptographic algorithm used to encode it. There goes the body with the actual information. And the footer is like the cryptographic signature. So the header, first of all, it contains information about the user. So here is the email. It also shows that the email is verified. Here's the name of the person, or if you prefer the name and last name in different places. The language. It also gives information about the group the user has been added to. This is completely custom. You can have users, nurses, caregivers, patients, device users, administrators, something like this. So it's not about permissions, it's more like about grouping users. And every group can actually have custom attributes associated with them. So you can configure some completely custom stuff about the user, like, I don't know, where do they go, what API they use, what sort of limitations, restrictions they have. So that's like a key value storage associated with the user or with the group actually, so you don't have to copy paste values. So this is personal information. It also mentions scopes. So if you requested email and got access to it, it's here. It also gives information about the roles that the user has. Like for instance, this one, it's like a custom role. It's just a name. It doesn't mean anything to Keycloak itself, but we can use it to see like, hey, if the user has the admin role, oh, they have more access than everyone else. So role actually can be used for access control. And the header of the token contains like, let's say the cookie information, something like this. So like expiration is how long does this token remain available, like the expiration time. Also who issued the token, what's the target audience, like the account is someone using the account. This is the application that's going to use, remember, the client. And you also get a session. So this is like you're signed in and your session stays active for a while. That's also a session ID right here. So this is what the access token contains. But You also have the ID token, which is like the token with the information about your account. So if we take the ID token instead, you see that you don't have roles here anymore. You only have the personal information here. So ID is basically like identification information about the user, like the user itself. And you also have a refresh token. It's not that important what it contains, but you basically use this token for prolonging your session on the server. So that's a request, the refresh token, and you see it has almost no information useful to the backend itself. Now the sweet part, as the administrator, you know that the user is signed in, and you can actually see the session right here. That's an active session. You can actually see what's going on there with the user. You can log out all sessions, and the user can actually sign in and do it themselves. So you can give users some access to this. And that's your session management right here. You can see actually who is doing what. And here is also a list of events in the system. So you can see that someone tried to sign in, that was us. And someone actually got an access token. So that's the backend actually doing this terminal stuff that I was showing. And you see there were some errors before while I was not able to exchange code for a token. All the information is still here. Now remember, this access token actually had some custom attributes associated with the user. You see, it's called user attribute and group attribute. That's just a custom name to show where it comes from. So a user attribute is actually defined here on the user. So you can associate like absolutely custom information, like any blah, 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 and any random value. And this gets associated with the user. So here you can configure some individual stuff, some restrictions, some limitations, some settings, something like this. Now, groups also have attributes. So first of all, this user is a member of the caregivers group. And the group itself also has attributes associated with it. And you also can add like random values here or see a list of users in the group. Groups actually can also have subgroups. So basically when creating one, you can like nest a child group here. And groups normally inherit something that you have at the top. They inherit properties from the upper level group. Now it's a bit complex here that when a user actually has an attribute, it doesn't mean that it will immediately get added to the access token. You actually need to configure a client scope. For demonstrational purposes, I actually created the attribute scope, and maybe you remember that we actually requested it. And attribute scope creates a mapper, which basically says like, hey, there is this attribute. I want it to be in the token. I also have this attribute, and I want it to be in the token. And for every attribute, you configure which token you want to see it in. Is it the ID token with the user information? Is it the access token with the access information? Or is it the special user info API endpoint which allows the backend to get information about the user using a token? So you can after you configure a mapper here and also give it a name, you actually get a field added to the access token, and this is actually called a claim. I think also in the backend, in the client, you also have to configure that this scope is actually used here. So that's actually quite a sequence. There it is. You need to have the scope here in order to get the fields, and you define whether it's a default or optional. Default means that everybody gets these values. Optional means you only get these values if you actually request them. So there is this thing with the Keycloak that people will have to request access to something, like to attributes, to admin access or whatever, and it can be either granted or not granted. Using the browser is not the only way how you can authenticate. You don't necessarily have to send users with the browser to a certain URL. You can actually authenticate right from the terminal and get an access token. You actually create an HTTP request, which is POST. You use this endpoint. You say that, okay, you're a client backend with that secret, which is not here or here, and you use the password flow. This is called grant type. And then you provide a username and a password right there as a form field, basically. And you also say that, hey, I want to get the profile and I want to get the attributes. Remember this custom client scope with some custom fields. And when you actually run this request, you get the access token, the ID token, and the refresh token. So this can be used in case if you want to implement your completely custom authentication, like, hey, give me your username and a password, and I will go somewhere and verify it. But there is an issue with this that you won't be able to sign up or to implement this I forgot the password thing. So it's much more convenient to actually send users to Keycloak, because that's where they can do everything they need for this user management. Here's how you use the refresh token. You basically need to get this value and keep it for a while until you need to get a new access token. And you just send this value to the server with an HTTP request. Oops. Equals. So this is a request. It still goes to the same endpoint. And now you use grant type refresh token and actually give this value to the server. And when you send the request, you get a new access token. It's completely new, and a new refresh token. So this one now expires in 30 more minutes, and you can still stay signed in. There is also this interesting authentication flow called device flow. This is normally for devices which do not have an input device, like a keyboard or something. And basically you cannot authenticate on this device because you can't enter anything. There is no browser, there is no keyboard. So this device can actually ask Keycloak, hey, I want to authenticate. And then on the screen displays something like a short URL with a code, or maybe with a QR code. And then the user goes there and authenticates with their own account. So this is how it actually works. The device itself has to send a request to a special endpoint, and there the device actually gets a user code, which the user needs to know, the one on the screen, and also a special code for getting results from this authentication. And then the device just keeps asking, hey, do you have anything? No, authorization is still pending. Why is it pending? Because the user on this page hasn't done anything yet. So the user is supposed to enter the code from the screen of the device or the QR code, press the button, then sign in here in the browser. This can be the mobile phone or something, and agree to sharing user information, and that's it. And now the device keeps asking about new information, and now they get a token. So a device can also actually get access to a realm if the user uses a different device, a smartphone, to authenticate on their behalf. That's quite an interesting flow right here. And probably the last thing to show here is that Keycloak also can allow you to define authentication flows. Like for user sign up, you can define which steps are required to be taken. And it also supports reCAPTCHA, so you can make sure that it's not a robot. It also allows people signing in from third-party systems like LDAP providers. And it also allows you to add users from Facebook, from Google, from GitLab or whatever. And you, when configuring a third-party provider, you need to have a secret so that your application is registered there. It's not only limited to Google, you can also add any other provider, but only provided they actually have OpenID Connect compatible endpoint. This one has, for instance. You just need to configure it, get a secret, and then on your login screen you will have two login options. Well, I can show it right now. Let's try again. And there are the buttons. Right now they don't work because I don't have a secret, but you can sign up with Google. And the system doesn't care, do you already have an account or are you creating a new one, because it's the email that identifies you here. So let's see how the sign up form works. You can enter a name and a name, a unique email, then you get yourself a password, and oh yeah, you can configure the policy about how complicated the password has to be. And now you are redirected to the application where again you get the code, and this code is something that the backend can use to get information about your user. You can have additional flows in the Keycloak system where the user actually has to verify their email, and this will work once we have email credentials right here, so the server can actually send emails. The cool thing that in Keycloak you can also ask users to do certain actions on their account. Like here, for instance, you can ask the user like, hey, you need to update your password. Well, it's too old or something. Or you have to go through one-time password authentication. Oh, you gotta verify your email. So next, if you do something like this, the next time the user tries to sign in, Keycloak will not send the user to your application, but first say, hey, you need to verify your email. And only after the user is done, the user is actually sent to the application.